Hi, today I'll be sharing what I've learned while exploring the Couchbase database. Let's dive in. First of all, we'll have a look at what Couchbase is. We'll have a short introduction about Couchbase, and then we'll compare it to the other databases that we've learned in my database management systems class. And then we'll have a look at who or what companies are using Couchbase, or who's the target organization or companies or users for Couchbase, and then we'll have a look at a Couchbase demo at the end. Before going further, I'd like to introduce myself. My name is Sema Amin. I'm a Master's of Computer Science candidate at Northeastern University. Here's a quote about Couchbase's mission, presented by Matt Kane, who is the president and CEO of Couchbase. He says that Couchbase's mission is to empower enterprises to develop, deploy, and maintain their most mission-critical applications upon their high-performance, flexible, and scalable modern database. So what is Couchbase? Couchbase is a key value and document database that's memory first, and it empowers developers to build responsive and flexible cloud, mobile, and edge computing applications that scale effortlessly. Couchbase is many things. It is a distributed database, so there's no more scaling or availability issues. It's a cache database, so no more cache invalidation or coherency issues. It is a database and a search engine, so no more crawlers. It's an operational and an analytical database, so no more ETL, that's extract, transform, and load, which is what we did when we combined MongoDB and Redis in class. It's also a desktop, mobile, and clusterable database, so there's no more compromises between server and mobile. Next, we'll compare Couchbase to other databases. Couchbase lists its competitors as MongoDB, Redis, SQL Server, DynamoDB, and Oracle Database. In class, we've explored MongoDB, SQLite, and Redis. I'm going to be comparing MongoDB and MongoDB and Redis combined in comparison with Couchbase. So the first comparison, or the pros and cons, I guess you could say, between the two is architecture. Redis and MongoDB combined, it's very difficult to scale from a single replica set to a fully sharded environment. To scale Redis, which is single-threaded, you have to manually partition your data based on IDs embedded in the keys, hash of keys, or some combination of the two. MongoDB struggles with the same scalability challenges. Scaling the Redis MongoDB stack requires a complex process and manual configuration to scale from a single replica to a fully sharded environment. On the other hand, Couchbase has a modern masterless elastic architecture where both the integrated object cache and the document database are supported with single node type. Scaling Couchbase on demand is simple. It's a push-button process, and you can add and rebalance data with only a few clicks, and then you're done. The second thing we could compare them with is the cost. MongoDB's inability to scale increases the operational costs. Both Redis and MongoDB use master-slave architecture that limits the ability to efficiently support many simultaneous or concurrent users with a single node. Beyond a few dozen concurrent users per node with MongoDB, we will end up having the performance of MongoDB rapidly degrading. Some businesses try to optimize MongoDB database operations by designing and implementing Redis as an in-memory caching solutions in front of MongoDB, which is exactly what we have explored and looked at in class, as well as done assignments in. This could alleviate the performance challenges of MongoDB for certain applications, but it doesn't completely solve the issue. It just ends up making you deal with more performance degradation by adding more hardware resources manually, which increases operational and costs eventually. Couchbase, on the other hand, is purposely built as a memory-first architecture with key value and fast catch integrated with a document database that is designed to efficiently handle large numbers of concurrent users. And it supports hundreds of concurrent users on a single node with little to no impact on performance. Next, we have replication and failover. MongoDB is significantly susceptible to data loss and inconsistency. The way that MongoDB handles replication and failover can result in lost writes and inconsistent reads. So if a primary goes down, MongoDB is most likely will suffer data loss or inconsistency. This risk is one of the reasons why MongoDB deployments need to be closely monitored at all times. The Couchbase data platform, which was purposely built for distributed environments, has an entirely different approach to replication. With cross data center replication that significantly reduces the potential of data loss and inconsistency. During a failover, Couchbase prevents two distinct nodes from accepting simultaneous reads or writes at the same time. Next, we have operational overhead. When this is something that we've personally looked at in class, is that when you're combining Redis with MongoDB, these deployments will require an operation team that has mastery in two very different things, and it is tough to be able to get them both to communicate. So because MongoDB cannot handle many connections and many concurrent users per node, companies need to add a dedicated third-party cache like Redis, and with Redis-capable engineers so that they could help MongoDB engineers meet their performance requirements for internet-scale enterprise applications. Not every person dealing with data or data engineering is familiar with both types of databases. So the need for the third-party cache can add both cost and complexity to a Redis Mongo deployment. Couchbase, on the other hand, is self-managing for most applications. It has a fully integrated managed object cache that completely removes the need for a third-party cache like Redis. The Couchbase engagement database combines a key value store and blazing fast cache with an open source document database, eliminating the need to hire different people for to have the knowledge of multiple technologies. Next, we have multi-data center deployments. So when deployed in multiple geographies, MongoDB can't perform all the writes locally. And that's mainly because of its master-slave architecture and its use of primaries and secondaries. MongoDB cannot perform all the writes locally when it's deployed across multiple data centers in different geography. Which means that it has to, at least some writes. It has to perform at least some writes to remote locations, which can increase the latency and degrade application performance. The Couchbase data platform is masterless, memory first, and its built-in support for cross-data center replication means that all writes can be performed locally rather than to a remote location. This capability minimizes latency to help optimize application performance. Next, Redis MongoDB lacks a mobile solution. They don't have a complete solution to support mobile applications. As a result, you have to write custom services for your mobile apps to access data in Redis or Mongo. And you have to write your own code to synchronize data on the mobile device with data in a remote server, and or forego synchronization and instead pull data from the remote server for every request. This means that your app always needs to have a reliable internet connection to work properly and may suffer performance problems due to network latency and repeated network round trips. Next we have time. So the Redis MongoDB team or package is time consuming to maintain and manage. Due to the architecture, the topology of MongoDB deployment can be complex and increasingly complicated as you try to scale it. Deploying MongoDB requires lots of manual configurations and includes numerous components, routers, configuration servers, arbiters, primary instances, and secondary instances. Couchbase, on the other hand, because of its distributed architecture, it is quite simple. Installing it and setting up a cluster is a fast and easy process with minimal components and configurations. And a multi-node Couchbase cluster can be set up in minutes, and adding or removing nodes is simple. Next we have the N1QL and MQL, or Nickel and MQL query languages. The N1QL is the Nickel query language is developed by Couchbase, whereas the MQL or the MQL is developed by MongoDB. Both of these are query languages that are created by these databases in order for them to be able to, for them to be able to manipulate the database more efficiently. The issue is that Couchbase, because it traditionally used SQL, the SQL language, and you didn't really have to learn this Nickel language. I would say that that's one of the cons for Couchbase, and that now they're pushing for the Nickel query language to be learned, and that's causing some users to have some problems in learning this new language and stepping away from what they were traditionally doing. The last thing is the free training to compare is the free training resources. All three of them, MongoDB, Redis, and Couchbase, have free training and resources to teach users how to start using these databases. MongoDB has MongoDB University, Redis has Redis University, and Couchbase has Couchbase Academy. And I've personally taken courses in all of them while I'm exploring these different databases, and I've quite enjoyed all of them. They are very similar to one another teaching-wise and material-wise, but they're all very useful while you're learning how to use these databases. These are some of the courses that I've taken at the Redis Laboratories, Redis University training, and these are some of the ones that I've taken with MongoDB. So next we'll look at what's the purpose of Couchbase. So Couchbase is designed to be used by companies that are wanting to scale or will be able to scale their businesses seamlessly or easily, and so it's targeting bigger companies or companies that are going to get bigger, or like scaling companies. A case study that we could have a look at is Viber. So the Viber app, if you're not familiar with it, it's very similar to WhatsApp, and it connects more than 1 billion users worldwide through high-quality audio and video calls, messaging, and more. To process up to 15 billion events per day, Viber needs scalable database performance, and the company implemented Couchbase in a multi-layered AWS architecture. And Couchbase updates user profile in almost real time and delivers a very responsive user experience. By replacing MongoDB and Redis with a single Couchbase database, Viber reduced the number of servers from 300 to 120. And this is the Senior Director of Operations and Chief Architect of Viber saying that with less than half the servers, they're able to increase their performance and gain a much better scalable architecture. And here is a demo of a Node.js Express using Couchbase CRUD application. The app is loaded into GitPod, which is a way to run the things that you upload on GitHub in your browser, so that you could easily share it, or in this case, record it. So first, I have the application loaded on the left side, and the code of the application loaded on the right side, the main code of the application, I should say. So first we import our dependencies and the database connection. That can be seen over here, and we're importing Express and importing Couchbase as well, and we're importing the database connection. And then in the connection.js file, we're also importing the Node.js SDK for Couchbase, and we're creating that connection to the database. So we could see that here. Here we're making the connection to the database from that file. And so after we have our configuration for the database connections in place, we can then create our Express app. And here we go. We're just loading our dependencies and making sure that Express will be working in the way that we intended to. And then here we're going to be ensuring that primary indexes do exist. So we create two primary indexes, one for our user profile bucket and another one for the profile collection. And the collection index is used by the /profiles endpoint that utilizes Couchbase's nickel query or N1QL query to search the database for profile documents where the first name or the last name match the search values. The bucket index can be used in case any documents are added to the bucket's default collection or manually from the Couchbase web UI. So now here we'll start looking at the code that is most relevant to what we looked at in class. And this is the post profile. So we create a profile document using the SDK insert method using profile collection. So first, if we look at the code here, we check that both an email and password exist. And then we create a profile object based on the data that was sent in the request. So I just shifted the screen a little so we could have a better look at the code. As I was saying, that we need to make sure that we need to make sure that both email and password exist, so this is what we're looking at. And then we create a profile based on the data that was sent by the request, and we create an async call to the profile collection using the insert method. So this is the insert method here. We're creating the async call that goes to that over here, and then we return the document saved and the results as part of the same object back to the user. We utilize the spread operator again to make this simple, and insert is a basic key value operation. Then we have a look at the get profile key. So this is how we would retrieve a profile by profile ID using the profile collections that we created earlier. We only need the profile ID from the user to retrieve a particular profile document using a basic key value operation. And we can catch the error if the key value operation fails, and we can return an error message with it. And then we have the, over here we have the put profile, and this is equivalent to the update or edit, we don't need to specify a PID because it will already have existed. We're updating something that we've already created. So we just need the profile information, like the first name, the last name, email, and password in this case. And the user may only be changing one or many, like they could either change one or a few fields in the document at the same time. So first we retrieve the existing document and check if there's any differences, and only update the fields that need to be changed. Also we have to first look up if the document exists first. If it does not, then we return an error that says profile is not found, and we cannot update the document. Otherwise, all the changed fields in the document get replaced, except of course for the document key and the PID key field. So then, after finally we create an async call to the profile collection using upsert method. So this would be the upsert method here, and return the document saved and result as we just did in the other profile. Next we have the delete profile, and we only use the profile ID to delete the user, just to be on the safe side and not remove a user by accidentally putting in a user with the same name as another user. And that's basically the main. That's basically the main ones. The main CRUD operations that is needed, and we could have a look now at the actual app. So here, if we want to post a user profile, we could try this out. And they've pre-filled this for us, so but just to be on the safe side and making sure that this actually does work, we will try it this way. So it was accepted, and so here we have the JSON file of what was just created. It created an ID for us. The email here is what we had just created, and the first and last name here. So then let's copy this ID. Where was it? Right here. The ID that we just created, that was just created for us actually. We'll copy that, and then we'll see if we could retrieve it in the get. So let's try this out. We will paste that here and search. So here we go. Here it says that here's the ID that we had, the CS5200 at Couchbase.com email, and the accompanying entries. For example, let's change that to try to use the put or the update method. We will again put the profile ID so it can pull which entry we're trying to change, and instead of maybe we could change the password to, or sorry, the email. We could change it to include this, and I could change it to my name. And execute. And here we go. So we have the JSON file that just got created. It has my name. The email was also updated. And notice that the PID that we had has not changed at all. And finally, we'll have a look at the delete method. So we'll paste this here, and it just updated it for us. So we were able to delete that. And just to make sure that it was deleted, we will just have a look at, we'll try to get it again. So let's see here, execute. So here we go, we have the error message here that says document not found, because we just deleted it. And that's all for the run through for the application and the code for the CRUD application, for this CRUD application. Thank you. Thank you so much for your time in looking at this and exploring Couchbase with me. I really appreciate it.